Okay. Just wondering. Lesson 89. Average value of a function and mean value theorem for integrals. Oh, it must not be whoever left their phones. Oh, I should have known by the sound of the heels that was Donna. See, it used to be that heels always made me think Mrs. Bailey. She might have been, was she before your guys' time?
Yeah, we were in fifth grade.
So you guys didn't know her as, but she always wore heels. And she's one you could hear her coming down the hallway. So, okay, guys. Average value of a function. When you see the word, find the average value in an AP question. Okay, average value, average value. You see that within a word problem any place. We need to think about this formula, and which basically is the integral. But in front of that integral, you have to throw in a 1 over b minus a. Okay, so it's still integrating, but it's throwing in that 1 over b minus a. So, definition of average value of a function. If f is continuous, so there's that restriction again, on the closed interval I, which is defined from a to b, where b is larger than a, then the average value of f is given by the integral 1 over b minus a times the integral of b minus a of f of x dx. Okay, so average value, the integral preceded by 1 over b minus a. Okay, watch for those words, because numerous times I have seen something like on an AP test or something, and I'll go to do it, and they'll put in the answer of just doing the integral versus the answer of 1 over b minus a in front of it. Okay, so average value is the key phrase. So let's try it out with example 1. Example 1 says, find the what? Average value of the function f of x equals x squared minus 10 on the interval -1 to 2. So if it says find the average value, what am I going to think?
That thing up there.
That thing up there. Okay. So they give us our f of x. What are a and b?
2 is -1.
Okay, and which one's which?
2 is b.
2 is b, because b is the larger one according to the rule, right? And that has to be true because of how we're setting up the integral. Okay, so find the average value. 1 over b minus a means I'm going to do 1 over 2 minus -1 times the integral of -1 to 2 of what function? X squared minus 10 dx. Okay? So what is that fraction out front? 1/3. Cleaned up as 1/3. So basically, the average value is going to be 1/3 of whatever the integral gives us. Let's go ahead and integrate. Integral of x squared. 1/3 x to the third. Minus integral of 10. 10x. Evaluated between -1 and 2. We're doing some basic math you guys are comfortable with, right? At least I think you are. I hope you are. I expect you to be at this point, right? Okay, my opinion is I'm going to leave that 1/3 out front, and I'll just take whatever I get in the end, multiply by 1/3. Start by plugging in 2, right? So we plug in 2. What do we have here? 8/3 minus 20 in that first parentheses. Fun stuff. Then we are subtracting. In the next parenthesis, I'm plugging in -1, which is -1/3 plus 10. 8/3 minus 20.
Negative 52/3.
Yeah, I was just debating. I don't really have it written out on my paper,
That's
so
too much work.
that's too much work.
Yeah. You can just do the negative 20 minus 10 is negative 30.
I see where you're.
8/3 plus 1/3 is 3.
Yep. Okay. So yeah, and this is where we all have to meet in the end, right? You individually have to go with where you're most comfortable. But I do see Daryl's point of 8/3 minus negative 1/3. So 8/3 plus 1/3 is 3. So that's 9/3, which is 3, right? So then I have a 3 minus a 20 and minus a 10. Does that make sense?
Yes, I like that much better than 52/3.
Yeah, I know. I took it that way. So I mean, So yeah, I agree. So 3 minus 30, negative 27. And I know if you guys have access to a calculator, you guys are going to grab a calculator. But this is a problem where you wouldn't have access to a calculator. Okay. So 1/3 of negative 27 is negative 9.
Solid.
We like it when that works out, right? Now, average value. Thoughts on what the negative on that means?
Close to the line is negative.
Okay. Majority of, the average value is below the x-axis. So more of the value is below the x-axis than above the x-axis, right?
That's only talking about on that interval, right?
Yes, on that interval. So negative indicates average value is below the x-axis. Okay, so you can't see what I wrote there, but if you want to put some thought there about what that negative means. Okay. Have you started B without me? No. Okay. Approximate the average value of the function f of x equals 4e to the 2x on the interval I, which is 0 to 3. What's it say right there? Average value. Notice it does say approximate, which we'll talk about what that, means in the end. And then the interval 0 to 3 means what?
A and B respectively.
Yeah, A and B. Again, remember B is the larger number. And that was by definition. So, here we go. What do I start with? 1 over B minus A. So, I'm going to write it out as 1 over 3 minus 0, but that's just because I'm setting it up. Times the integral of 4e to the 2x dx from 0 to 3. Okay, so out front we have a 1/3. I'm going to go ahead and write down the 4, because that 4 is a 4, right? And then that just means that I am integrating e to the 2x is all my brain has to comprehend right now. So when we do derivatives or integrals of e to some power, it's what? E to some power. So it's still going to be e to the 2x. But if we were doing the derivative, we'd have to multiply by 2, because the derivative of 2x. So to compensate for that, we're going to say 1/2 e to the 2x. Does that make sense?
Just leave it as 4e to the 2x and then just put 2e to the 2x.
Like, instead of writing this 4 here, write 2e to the 2x? Yes. Yeah, you can. Okay, and all this is going to be evaluated from 0 to 3. Now, if we take that 4 times that half is 2 times the third, my opinion is just, okay, what is all that mess? That is 2/3, right? And then I don't have to worry about, getting all those numbers in there. So e to the 2x from 3 to 0 is going to be what? E to the 6th minus e to the 0. Should I just drop off that e to the 0?
No, it turns into 1.
Yeah, it turns into a 1. I feel like that happened recently on a test or something. Not yesterday's test, but no. It happened like maybe to someone on the previous test or something. Or maybe it was just in homework we talked about it. But okay. And so an exact answer would be 2/3 times e to the 6th minus 1. And if you're not using a calculator, this is what they're going to expect, some variation of this form. Okay? If they're using a calculator and it says that approximate, it might very well be a decimal answer in the multiple choice. It just, although, yeah, I don't know. So we could also give an answer of 268.2859. Isn't it though? Okay. Average value of a function is not difficult. Okay. There are some good AP questions with this in it. Okay. Even on the, I always want to call them open-ended, but free response questions, you'll see them throw average value in. So just watch for those words and remember, oh yeah, integral with the 1 over b minus a in front. Okay. The other part of our lesson today. Mean value theorem for integrals. If f is continuous, love that restriction, right? On the closed interval I, which is a to b, there what? Exist. So this is another existence theorem. Just saying that something exists. So there exists at least one number c between a and b such that f of c equals 1 over b minus a times the integral of b over a of f of x dA. So they are saying that there is some number that is going to be equal to the average value when you plug it in. So like some value c between a and b, when you plug it into the function, is going to be equal to the average value of the function. So basically it's saying at some point that function equals the average value.
Makes sense.
That's the best way I can explain it in non-calculus terms. Okay, but that's what this theorem is saying, is that such a value exists. So like up when our first one, the average value is -9, there is some value in that interval from -1 to 2. When I plug it into the function, it equals -9. And that's what this is saying. So let's look at example 3 here. Given that the average value of f of x equals 2x cubed on the interval 0 to 3 is 27/2. So they've already done that for us, right? Use the mean value theorem for integrals to find some number c such that f of c equals 27/2. Okay, so given that the average value is 27/2. So notice this part right here, the 1 over b minus a times the integral, that's saying that's equal to that, right? If we did all that math, that would be equal. Now, so there's some value c, and that's our goal to find. There's some value c such that when you plug it in, our function will equal 27/2. So, Trying to find the value that makes f of c equals 27 halves. What is f of c? 2c cubed. Because if f of x is 2x cubed, when you plug in c, that makes it 2c cubed. Yes? Do you see where I'm going with this? If f of c is 2c cubed, if f of c is also 27 halves, then do stuff with it. Do math stuff with it? Okay. Do algebra stuff with it, basically, right? 2c cubed equals 27 halves. So divide by 2, which is multiplying by 1/2, and it is 27 fourths. To find c, we're going to do the cube root of 27 fourths. And that is your exact answer right there. I have a decimal written down. So c is approximately whatever the cube root of 27 fourths is. I don't like that answer. I like that answer better.
Oh, I did disagree with you. That's fine.
Okay, there we go.
Silly goose.
I was debating if you know, where the mistake was, so.
Yeah.
Calculator error, regardless. 1.8899. Don't forget to hit cube root.
So is that like the x value where the y would be 27 over 4?
Yep. 27 over 2.
Yeah.
Yep. That is the value. And notice, it's on the interval from 0 to 3, right? And so if you take that 1.8899 value, which, so if I take, almost forgot to get my cube root. So cube root of 27 fourths, right, is this lovely value right there. Okay? If I take that lovely value and I plug it into what was our function? 2x cubed. So 2 times, I'm going to copy that paste from above, to the third. Notice it's 13.5, which 13 point, really? Okay, my calculator did not want to make 13.5 a fraction for whatever reason, but 13.5 would be 27 halves. Must not be an exact 13.5 in the calculator brain somehow. I don't know, I feel like it should be, but okay. Okay, down below, there's a 2 already listed there, and then because we skipped 87, I have 2 others written in there. Okay, already listed as problem 1 needs to become 7 from 77. Problem 3 needs to become 23 from 86. 14 and 16 become 20 and 21 from 87.